Welcome everyone to a new episode of the Haptics Club podcast. I'm Manu from Unity, and I'm joined by the Haptics crew, Brian from SenseGlove, Eric from Razer, and Ashley from Titan Haptics. The Haptics Club is a team of people that have a passion for haptics. Our goal is to raise awareness of the amazing tech and people in haptics and to foster interesting discussions on the subject. Check out our new store, thehapticsclub.com/shop, and our blog, thehapticsclub.com/blog. Joining us today are Christian and Max, distinguished members of Team Nimbro. Christian is a distinguished PhD candidate at the Autonomous Intelligent Systems Group of the University of Bonn, while Max serves as accomplished team lead of Nimbro. Together, they spearhead an exceptional project that emerged victorious of the ANA-AVATAR Xprize, a globally renowned robotics competitions of the highest stature. There is much to learn and talk about. We will divide the hour with a 5-minute intro, then dive into areas of expertise, and then the future of haptics. We will, of course, cover challenges and opportunities of the haptics industry. Be sure to visit thehapticsclub.com and sign up for our newsletter so you don't miss the next episode in 2 weeks. Last but not least, we wouldn't be able to be here without sponsors like the Haptics Industry Forum, a haptics association which was created to streamline haptic standards and adoption, foster collaboration, and increase market awareness. Enough intro. Let's talk haptics. Back to you, Eric.
Christian and Max, welcome. It's a pleasure to have you here. So, Max, tell something to our listener. Get a little bit introduction about yourself and how did you start with haptics?
Hi, everyone. I'm very excited to be here. I'm also a PhD student at the University of Bonn. Chris and I started around the same time. And I think it's safe to say that we lead this project together. What we have developed is an avatar system, so that allows a human operator to be present in a remote space and to interact with a remote space, like touch objects, manipulate them, talk with people, anything you can imagine. That's the goal of our system. And I think this is also like the first real in-depth connection we had with haptics.
Fantastic. Thanks, Max. And Christian, to you, a little background on yourself and how did you start in haptics?
Yeah, hello. Thanks for having me. I'm Christian Lenz. I'm a PhD student at the University of Bonn. And my research interests are robotic manipulation for both autonomous and more recently for teleoperated robots. And as Max said, we developed these avatar systems over the last 3 years. And of course, haptics played a important role because being able to feel the objects is one thing which was really necessary to solve the tasks and feeling present in general in the remote space. So that was the first contact for me as well, exploring the world of haptics and finding solutions for our system to provide these capabilities.
Wonderful. Thanks for your intro. Let's dive into this challenge and the avatar robot that you built. Before diving into technical specs, some of our listeners probably don't know what is it. Can you give us an overview what is the Xprize in general and specifically the ANA-AVATAR Xprize?
Sure. So,
yeah, Christian.
Xprize Foundation is located in the USA and tries to find really interesting research topics the world should work on. So they have some proposals and some get through, and then they search for a sponsor funding this activity. So there's no funding for teams developing the system, but there's like a big prize fund teams aim for. And by this, they have lots of different interesting topics people get motivated to work on. This avatar competition in particular was the first one towards robotics. And it was designed to connect people over large distances and was sponsored by ANA, the flight company from Japan, who thinks this is one of the opportunity to travel in the future to teleport in some sense, like in quotes, to remote spaces.
Oh, that looks amazing. I know that it's a long tradition from Xprize to found extremely crazy, let's say, ventures. I think one was also from SpaceX, right? That they got one Xprize when they had these milestones to arrive to first private company to arrive in orbit. I mean, it's great to see that there is a little bit part of haptics in these things. It's not exactly all haptics. It's more about telepresence, these kind of things. But that's pretty cool. So, but let's maybe dive in a little bit. So, Max, this is to you. Can you a little bit describe the technology that your team developed and how it works?
So I think all in all, you need many components to build a successful avatar system. So I think this is the most complex system we have built so far in our lab. It includes a technology like video streaming. I mean, the operator wants to see what the robot is seeing, but also in the other direction, persons interacting with the robot want to see what the operator looks like. So we also have a solution for that. There's audio connectivity. There's telemanipulation, so being able to move the arms of the robot and also the hands, the fingers. There's tactile feedback, there's force feedback, and there's also a subsystem for locomotion, so to move the robot around as you want.
That's great. But in your opinion, it was more like a challenge of system integration, basically making this subsystem that were existing, or it was pretty clear how they would work in a standalone, and the problem was synchronizing them, putting them all together, make them work all together in a reasonable way? Or did you have to build some specific technology in some of these area that allowed you to get the edge over the competition because you won this competition? We'll discuss about the competition later, but it's more a challenge of systems integration or more a challenge of any type of these let's say technologies that you have to do some key advancement that it was not present before.
Yeah, I think in the end it's both. I mean, we needed to identify like key points where it was necessary to push beyond what is simply available to buy and innovate ourselves. In other areas, I think we could take what worked before and just apply it. But then on the other hand, like system integration and also system robustness really played a role in winning this competition, I would say. So there were a lot of competent teams there and amazing technologies that were demonstrated. But really, a large part of the teams also struggled with robustness and making sure that everything worked when it was time to go.
That's great. I want to ask the next question to Christian this time. So as spectators, we only see a single performance of the robot doing all of those impressive interactions. Can you tell us a little bit more about how much time that it takes actually to build the system that you participated with and what the process looks like?
Yeah, sure. So we developed as the core team working on the project started like 3 or maybe 4 years ago. So the competition is already half year in the past. So we worked around 3 years on the project. And of course, we started really simple by having one arm just bolted on the table, another arm on the next table, and trying to interact with one arm on the other table. And then exploring in a large variety of different solutions. For example, at the end, we ended up having a head-mounted display for the operator to see really immersively what's going on the other side. But we also tried to have like a cave system, so some beamers, projectors projecting the image on the other side. So we spent some effort in this direction, and slowly parts came together, and then this integration effort had to be overcome, and we had to get the system running. And then one important part is testing. You need to test the system, especially if it's a complex system. There are always edge cases you are not thinking about while developing, and you need to find them and then to tackle them. And making this testing as realistic as possible is really necessary and one key.
Which part do you think was the most complex out of all of those ones that you mentioned, or was it the testing that took the most amount of time?
Oh, that's an interesting question. I think figuring out which sub component is the best for the particular task was one really important thing, and was maybe not so clear because we are quite a small team and we have limited expertise in all the different areas you need to solve. So jumping in a different area, for example, haptics, we did not really have much experience before.
Uncharted waters.
Sorry?
Uncharted waters.
Yeah, and exactly.
Thank you.
Fantastic. Thanks for the answer. And let's go back a little bit on the challenges that you faced. You mentioned twice robustness as being a key differentiator of this competition. Did you find a trade-off between the fact that you had to have a really robust technology? So maybe some of your competitors were more advanced in some area, but basically what happens is that just their system just didn't work. And at the end of the day, the most important thing is the deliver value as usual. So robustness is probably the most important characteristic of any functioning system, right? So were there any key innovation that you saw in the other teams that you would say, oh, this is great, I would like to introduce it like in the future version of my robots? Or you were more or less, all the teams more or less at the same level in the technology side, and it was a difference really about robustness and testing?
So maybe I can take one example. Like, for example, there was a team called Converged Robotics who had really amazing tactile capabilities. They used the Haptics gloves for operator feedback and biotech sensors on the robot side to really measure haptic signals quite precisely. And I believe their like finger tactile system was much better than ours. But in the end, they unfortunately got knocked out quite early in the finals because the robot unplugged a cable on itself, and the system completely stopped after that.
Self-sabotage, no.
Yeah. So things like that. I mean, they can happen, of course. And the only way to catch these is to test extensively, to really have enough test rounds that you are aware of the weak spots on your system and know how to treat them.
I like this because it's the most German answer I can ever get out of anybody. You won, so guys, this is how you win. And thank you very much for your answer. And going back to Christian, I want to dig more a little bit. You mentioned before, Max, the fact that you had to innovate on some area. Can you enumerate the area where you had to innovate besides system integration, where you had to do some key advancement for to have this avatar system working?
One thing Max already mentioned is that it's important that the operator can see what's going on the other side, and therefore we developed a system where the avatar's head is mounted on a robotic arm, so the head can be moved freely accordingly to the operator's head movement. And I think that gave us an edge in the competition because the operator was able to really look around things. So the humans do this movement by moving the upper body, but we do not have these joints or these actuators in our robot. So a more head movement than just rotating the neck was really one thing we pushed forward and developed for this project. And another thing is visualizing then the operator's face. So right now we're talking over Zoom and we can see and hear each other clearly. But when some of us has the VR headset on, we block the eyes, and we have some system which renders an image taking into account the movement of the mouth and the eyes from 3 cameras and rendering a really realistic image of the operator. So the people on the other side have really a feeling that the person is there. And then we experienced some things towards haptics. For example, we have the haptics, the Sense Glove DK1, and they are really nice because they have really accurate joint measurements from my experience. and they have the brakes which allow to display the human some interaction force, but they do not actively pull on fingers. So we thought if you feel with, like humans would feel with a finger on surfaces without applying too much pressure, and then it would be nice if the finger is lifted a little bit actively. So we spent some time investigating or doing research in this direction. At the end, it did not play such a big role, but we have some things done in this direction.
I like those examples because it's like those teeny details of magic that just makes the whole thing a bit more believable. So thank you for adding that.
Yeah.
Max, how did you and your team feel about the final testing event now? So where you had to demonstrate the capabilities of your avatar system in front of a live audience. I think it was more than 2,000 people, 2,100 actually. Were there any surprises or unexpected challenges there?
So first of all, I thought it was quite nice of Xprize to do this as a public event, so really that anyone could join in and feel the excitement. I think we went in on the one hand quite confident because we got the first place in the semifinals as well. So we already knew that our system was capable and we had confidence in it. But of course, I mean, time doesn't stop, and we weren't sure what the other teams had been doing in the meantime. So there was kind of nervous excitement about seeing the other teams perform, I would say. That sums it up for me, I think.
I want this to be at the next Olympics at some point.
Maybe to add something from my side. We also weren't sure what Xprize will bring. So we saw the arena and all the tasks really built just on the competition day, or like in the first qualification day or the day before. So we had, of course, rules stating what the task will look like, but the small details, which might matter a lot in the end for such complex systems, were unclear to us. So it was the first moment we were allowed to go in the arena and see what really were the task, which was really interesting.
Yeah, that's right. We also spent, I mean, the last months up to the competition, we spent like preparing for every eventuality of how the tasks could look like, especially the last task, which involved feeling stones and feeling their roughness. We weren't given much information about this, so we tried to prepare like for everything that could happen.
Maybe can you give us like an overview of the task that your avatar system had to overcome in the finals?
Should I?
Yeah, go ahead.
Okay, so there were 10 tasks, and I think the most important thing to emphasize is that not us or some experts from our side control the robot, but it was someone from an international expert panel. And we did not know our operator just 1 hour before the run. So we had no idea who will control our robot for solving these 10 tasks. And we had to train them for 1 hour at most to get them comfortable and successful with our robot. And the 10 tasks this operator then had to solve was some sort of locomotion. So the first task was just driving 10 meters or walking 10 meters. Then there was the recipient judge, so a second judge in the arena located at the robot, next to the robot, and they were communicating. So they had to introduce themselves, they had to listen and repeat some instructions. And then task number 4 was the first manipulation task. There was a power switch they had to activate. Then there was a longer distance to travel, around 40 meters, I would say. And task 6 and 7 involved again manipulation. There were some power canisters they called it. It's like bottles which had different weights, but they were not visible from the outside. So the operator had to lift 2 or 3 cans and see which is the heavy one, and then put it in a designated slot. And task number 8 was navigating through some narrow passages. And then the hard task, so the task got harder and harder. Task number 9 was grasping and activating and using a power drill to unscrew a screw, which then opens a hatch for task 10, where some artificial stones were lying, and they had different texture. One was like some of them were rough and some of them had smooth surfaces. and the operator had to distinguish the rocks by touch alone. So they were able at the end to see it. That was something we were not sure in advance if they are able to see the stones or not. They had the chance to see them, but the independent objective operator had to really judge if they were able to feel the difference between the surfaces. And then they had to retrieve the stone as the final action to solve all tasks.
And how many teams were able to achieve the 10th spot?
There were there were 17 teams starting in the finals, and 4 of them completed all 10 tasks. But I'm sure, as Max already mentioned, I think there were some more teams who would have been able to solve task 10, but they eventually did not get there because of
it was sequential, right? So you had to pass one to go to the next one, correct?
Exactly.
And the last 4 teams were judged by the judges towards some metrics over each step, or it was like a time-based competition? How was it?
So the scores were given based on the task completed. So each completed task was worth 1 point. And in addition, the system was judged by the operator, but also by the recipient, worth for 2 points. 1 point was for if they were able to easily see and hear the other person through the system, and the other one was if they were feeling present in the same location. And 1/5 bonus point was from the operator judging if the system was easy and comfortable to use. So at the end, it was 10 points for the task, and then up to 5 points from the judges for a total of 15 points.
That's very impressive.
Ties were solved by time.
By time, okay.
Yeah.
So on top of the point, you had to do it as fast as possible to get additional points based on the time, maybe?
No. Just
a ranking, I guess?
Yeah.
Okay. You mentioned, I think, between task 4 and 8 that both were about locomotion, like 40 meters distance or narrow spaces. Were there any obstacles? Like blocks or things that are hard to pass by, things like that?
For task 5, I think it was 5, the longer distance, it was just 5 meter wide corridor. Task 8 was much shorter, say 20 meters, 15 meters, but there were some artificial rocks really lying around. But there was some really clear space in between, like 1.5 meters or something. So it was more, in my opinion, is the operator able to get enough situational awareness? Do they know how close are they to the rocks? Do they know there's something behind them? Instead of really finding a way through this box.
And were you just using, telepresence based on direct sensory stimulation, like your 3D camera, stereo 3D camera with VR, and audio with the binaural, microphone with binaural audio, and hands, or were you also equipping with, LiDAR, and you were having proximity indication, pretty much like cars, it would beep if something was near to help the navigation?
Maybe I can try to answer this. For the most part, we discovered that it's best to have one-to-one correspondence and one-to-one sensory correspondence. So we try to feed the data directly as possible to the operator and use the same sensory mechanisms that the operator would use. That feels the most natural. But for example, there are some assistance functions we built in. So we anticipated that the human operator might not be able to see the stones and still would have to feel them. And that's very difficult. I mean, if you're talking about blind manipulation and without seeing your hand, even with very advanced today's tactile sensors and so on, you would have problems finding even the stone, let alone going over the surface to feel it. So we added like a depth camera that would kind of measure the scene and show it to the operator like an overlay, without showing them the surface of the stones, but showing them the location, and then they would be able to get to them and feel them.
That's super cool.
Yeah, I was exactly asking myself this one, because if you're using the Sensor Globe, it's it's a great haptics device for the purpose that has been built, which is for virtual training mostly, but it's not a high fidelity haptic device with yes ERMs right in the fingertips, so that their capability to render textures is it's not the strength of this device. And what was the strategy that you used to allow the user to recognize textures?
Yeah, so the analogy that we developed is like the operator would feel like they were wearing a thick glove or something, like a metal glove, like a knight's glove maybe, and if they move across the surface, then you might not be able to feel the individual bumps like moving by, but you would feel the vibration of moving over the texture. And that was the channel we exploited. So it's not like a direct spatial display, like maybe the haptics gloves or similar products, which are able to like raise individual pins and make you feel little bumps on your skin. It's more like vibration feedback. Yeah.
Do you know if the texture, I would say, precision of that roughness versus smoothness of those artificial rocks were very, narrow, or more like completely on the huge spectrum?
Yeah, so if you feel them as a human, you would say it's very easy. It's like immediately obvious that this is rough and this is smooth. But I mean, we tried it with like a multitude of different sensors, like force sensors, small haptics sensors. We tried. In the end, what we were going with is audio actually. So we recorded the vibrations using audio technology. But still, in all of these signals, it's not that obvious if you look at them, and if you also use simple maybe classification algorithms or so on. It's not immediately obvious that one is smooth and the other is rough. So the problem is much harder than it looks at first glance.
Do you feel like you had to combine some of those, like audio plus haptic, to get like an accurate answer from the judgment?
Yeah.
Or was it just the computer vision and the physical that helped?
So I think for making the observation, so for letting the operator move their finger across the stone, it was necessary to have like haptic feedback with force feedback also, so that they could feel how much of contact pressure there is and how much they are moving. And then the audio channel was more used to make them feel the texture and help with deciding, is this rough or smooth. Yeah. So in that sense, yes, we had to combine several sensor modalities to do that.
That's interesting, because it's it seems that the bandwidth of rendering or measuring and rendering of the system was not enough, and you used the sensory substitution strategies to convey the same results. That's definitely interesting. So it's not exactly one-to-one, but you found ways to go around the limitation of the hardware, and that's impressive. Congratulations. Maybe we can let's say move to the next section. What do you think, Manu, about the future of haptics?
Yes, but I have one last question.
Yeah, sorry.
I'm excited because I love robots. Okay. So Christian, for you, now that you've gone through that event, if you had a different way to redo it, would you do things differently?
No, that's a great question. I mean, I think we did a lot of things right based on that we won the competition. I think we spent some time investigating and trying multiple things which did not end in our system, which might not be necessary from my point of view today, but it's hard to say. I mean, otherwise, I think we did some good choices in some subsystems, and I think, as we already said, the robustness and monitoring of the system was the key feature.
We were perfect. We would not do anything differently. I'm kidding. So what advice maybe you would give to, let's say, someone that is now going into a competition like this? What is something that your team would give as an advice to someone else, to another team?
I think it starts really simple by saying, like, really read the rules. It sounds completely obvious, but knowing what things will give you points at the end and which are not, and what components do you need to solve these tasks is a really important thing, which is easily forgotten by people just developing their systems. And also, you don't need necessarily the most complex solution for a particular problem. Easy solutions which just solves the problem are more beneficial in terms of maintenance and robustness and so on and so on. So and your system will be complex enough at the end anyways. So go for the easy solutions which are suffice and will do the job, and then pay attention to the things where you have to push the limits. And I think one thing, especially for the haptics problem, was to work on multiple things at the same time. So if we increase the sensors of the hand and really able to feel a lot of different modalities, but we can't display them to the operator, it's like work in the wrong direction. And the same applies to a lot of different things, in my opinion. Always work on the weakest link and then getting everything up one by one, I would say. I mean,
thanks so much.
Yeah,
I mean, that's
having a limited.
At the end of the day, it stays a competition, so you just have to be prepared too, also of facing the unknown sometimes.
Yeah, that's engineering 101 there. So I love it. Don't overcomplicate. Make it easy if you can.
Make it simple.
Keep it tight.
All right, so we'll move to the next and my favorite section of the interview, which is the future of haptics. So I'll start with a question, maybe for you, Max. What do you see as the future of avatar technology, and how do you think it could impact society and improve lives?
So I think if avatar technology continues to develop in this pace and is really usable for everyone, then this will have a huge impact. I mean, we know that travel is like a major source of cost, of time that is lost, of CO2 emissions, of many bad things. So if we can reduce travel and make it easier for people to be in a remote space, that has huge impact on society, I think.
Thank you. Eric, you want to ask the next one?
Yes, great. Thank you very much. So you shared about what it could be, but did you already have or had or are currently developing do you have any short-term commercial applicability for an avatar system like yours or a subsystem? Because it may be overkill for something, but basically can spin out a subsystem of this one and make it any type of commercial applications.
So we are looking at this. It's a bit difficult because if you want to sell the whole package, then it becomes immensely complex. As you can imagine, there's like I don't know, 100 things that are still need to be improved until we can give this to a customer. So this road is a bit difficult. Single subsystems are maybe interesting. So like maybe our movable head can be like an upgrade over video or over plain video communication. If you can look around and focus on people and make them feel that you are looking at them, that's really already like a step towards telepresence.
Isn't there the latest robot of Amazon that does that? The latest small robots of Amazon that they published that it can do video calls and it has a face and he actually looks at you when you call him. It's like a robotic pet. You call him, he turns at you, he looks at you, and the reviewer said that it's actually make you feel that he's there because he has a situational awareness of where you are, is looking at you. So that might be a good option.
Yeah. I mean, in that case, it's like the recipient controlling the gaze direction. In our case, it's the operator that can actually look around and control the robot. So we might have a point there.
If you use like a spatial audio from Apple, spatial audio that you get your directionality of your head, you could transfer that on the other side through API and make it turn.
Yeah. But it's a bit hard for us to think about like commercial applications because we come from the science direction, and we at our lab all we have done so far is like pure science, and that makes it a little bit hard for us, I think, to think about applications.
And how do you see telerobotics, or this telepresence, evolve in the next 5 years? So what do you see coming that you would have loved to include, but it was just a little bit far-fetched and not ready, and what you would love to do, in 5 years? Where do you see your same system that you have in 5 years?
So, okay.
Then Max.
Yeah, go ahead. All right.
Christian,
from my point of view, I think, for example, Haptics announced their new gloves. I think to explore things in this direction and increase the also maybe special rendering of haptics from the remote location would be nice. I think in other direction, or from another point of view, if I would design the next avatar competition, what challenges would I give? And I think can be solved then is definitely more locomotion complexity. Right now it was just level floor for everything. So wheels had a huge advantage over legs, but I think that's that's maybe suitable for a lot of applications where humans live and interact. But I think if you imagine bringing an avatar robot in a location where it's dangerous for humans to be, then there's definitely no leveled floor. And I think research in this direction to have a robust locomotion system which can get over some obstacles is something I see which will be possible in 5 years for sure.
Thanks a lot for the answer. And before closing, would you like to share, Christian and Max, if someone wants to get in contact with you, when can they find you? Oh, Max, you can go.
Okay. So we have a website. So this is maybe the easiest way to find us, which is ais.uni-bonn.de. And there you can find our team and also find all of our stuff, and also our mail addresses and so on. So it's easy to get in contact with us then.
Wonderful. Thank you. Thanks so much, Christian and Max, for joining us. It was a great conversation regarding haptics, telepresence, and telerobotics, more in general, also engineering. Loved it. And it was fantastic. And for anyone listening, to be sure, check thehapticsclub.com and follow us on LinkedIn and Twitter. Our blog is now live and featuring an article for your favorite optician. So if you're an optician, you want to submit an article, don't hesitate to submit it. We are happy to taking external contribution and evaluating them for our blog. If you want some Haptics Club swag, buy a Haptics Club t-shirts, help us sustain this community, or a hat or a sweatshirt at thehapticsclub.com/shop. Catch this episode live on YouTube and on every other podcast or major platform like Apple and Spotify. And see you in the next episode. Bye-bye.